in descending powers. So this also shows you how you do the expansion. So given this, if they ask for the first three terms in descending power, okay, then basically you just write down the three brackets first. Three terms, so 9 brackets. Just write it down first. Of course, you need to plus dot 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 because this thing does not end with the three terms. Okay, it has many more terms, right? So power 7 actually there is a total of 8 terms. Okay.
Okay.
If you need to get the full expansion, so what you do next is you write down the x here. You write down this here. You write down the x here. You write down this one first, which means first is the first term x. You put it here. The second term, which with the minus sign, you put it here. So you just put it in first. Then after that, you put the 7 here. You put the 7 here. You put the 7 here. Okay. Yeah. The next thing you do is because they want the first three terms in descending or power, right? So therefore your 7 must be here. Then if your 7 is here, this one has to be your 6. Then this one has to be your 5, right?
Yeah.
Then if this is 7, right, this has to be 0. Then this has to be 1. This has to be 2. Why? Because these two add together should give you 7. Okay? Then after that, it's pretty simple. Then this one has to be 7. This one has to be 1. 1 or 6? 6. This one has to be 5. Can you double check for me?
No,
is it 0?
Choose 0, yeah.
Choose 0. Oh, okay, good. Actually, I need to look at the formula also. I have not done this for quite some time, so. But anyway, usually when I make a mistake, I will realize it because I always refer to the formula after I fill it up. So let's refer to the formula. Yeah, formula. Okay, look. N choose 0 is when a equals to the power n, right?
Yeah.
Good. So it should be 7 choose 0. Okay?
7 choose 0 is 1.
Yep, yeah, I know. So I'm just telling you, if you use n choose 7 at first, right, it's wrong. If you look at the formula. So that's how you counter check. Alright? Alright? So this is 1. Then this is x to the power of 7. Then this is 1 because anything to the power of 0 is 1. Okay? Then 7 choose 1, I think it's 7.
Yeah, 7 so, 7.
Then over here is itself. Then 7 choose 2.
7. Oh, found it.
You see? You have not you have not played with this for so long. Okay, so the square will go into each of them, right?
Yeah.
So you go to the negative, it will become positive. So it's k square. So it's x4. Just now I said the square into the negative 1, it will become positive. So that's why you end up with this. Remember the dot dot dot. Yeah. Then after that you just simplify. So the negative will come out. I think this one is very easy already. So it's x6x, so x4, so it's minus 7k x4. Then this one x, okay, so it's x. Very good. K square. So I put the k square in front of the x. Okay. Then plus dot dot dot. Okay. So the convention is you put the k square in front of the x. Okay. So that's the first three terms. So 2 mark gone. So explain why there is no term which is in the yeah. So the second part, right, actually will test you that general formula. Why there is no term which is independent of x. Independent of x means x to the power of 0. That means they ask why there is no term. That means why there is no x to the power of 0 term. That's for part 2. Independent of x means independent of x means x to the power 0 term. Okay, they mean the same thing. So why? Do you still recall the general
when
formula?
I look at my notes,
Yeah.
you put like A and then B.
Yep, yep.
And then you add them up must equal to 7.
They say there is no x to the power 0 term.
Yeah.
Yeah, correct. But how do you do the x to the power 0 term? So you do the same thing. You give it 3 brackets, okay, and then the x is here. Then the this one is here. Then the 7 is here. So now you want it to be x to the power 0, right? That means this x and the x2 here, somehow you need to cancel out and get x equals 0. That's the meaning of it. Something x to the power 0, right? So, okay, you have done what? You have done 7, 0, you have done 6, 1, you have done 5, 2, right? So that means all of this, it will give you x term, right? So you only have what to play with? You only have like 4 and 3, right? And 3, 4, right? Right? Am I right? Okay, so if let's say I play with 4, 3 first. So if this is 4, this is 3. Now I remember already. If this is 7, this is 7, this has to be 0 because 7 minus 0 is 7. If this is 6, 7 minus 1 is 6. Yeah. Okay, so if you put 4 here, this has to be 3. So if you put 4 here, this one will be what? You will end up with x to the power negative 2, you know?
Yeah.
Can you see?
Because
if 7, 0 will give you 7, 6, 1 here will give you x to the power 4, 5, 2 here will give you x, and then the next term you check is 4, 3, which is x to the power minus 2. Basically, it will skip the x to the power 0 already. So x to the power 7, x to the power 4, x, and then it will skip to x to the power 2. So that there's no x to the power 0. That means if you continue to play with the 3, 4, you will go more negative only. Right? So you don't even have the x to the power, you don't have the x to the power 0.
So
Okay?
like, how do you, like, in the end, how do you say?
So you check for this 4, 3, and then it happened to be x to the power minus 2, right?
Yeah.
So there is no need for you to check for the rest. So you can say, so if this is x to the power negative 2, okay, then it skip the x to the power 0 term. Okay, so therefore there is no x to the power 0 term. Okay, or there is no term that is independent of x. Use their use their own words. Okay.
So then what if like the first 3 terms is already like not enough, but only you have to go like much more, and then you find out that it's not x power 0, there's no x power 0 term. Then how do you do it?
So for this question, you use this way. For other question, then let me finish this. I will refer you to that video. Then you can note down that general formula. Seems like maybe the general formula is lost in all your notes, but never mind. We will get it. So the coefficient of x to the power 4, right, in this is 7. So you see, they want the coefficient of x to the power 4 in the expansion. So this is also a very common question. By the way, I can guarantee you, so binomial expansion sure come out, and it's very likely to be this type of question. So they say the x to the power 4 term after this is the coefficient is 7. Yeah. So how? So I can erase this. So how? So you just ask yourself, can you see the 2 here?
Yeah.
Yeah. Hello. So this 2, right, times this will give you negative 14k x to the power 4. So that's one x to the power 4 term after the expansion. Right? Then another one. How do you get x to the power of 4?
Oh,
Is this one times this one? That will give you what? That will give you plus 21k squared x to the power 4. The rest don't matter.
Oh yeah.
Can you see? So that means when it comes to binomial expansion, right, you need to learn to be selective. They want x to the power 0 term, you pick it out. They want x to the power 4 term, after the expansion, you also pick it out. So after this, you will get what? So you will get minus 14k plus 21k squared. So this one is the coefficient of x to the power 4, right? This one? I mean, yeah.
Yeah.
So you just equate this to 7. Then you will end up with a quadratic equation. Then you solve the quadratic equation. Are you clear? So you bring it minus 7 equals to 0. So before you do the thing, you need to use the factorization method. Yes, I cannot emphasize enough. So before you do this, you can actually take out the common factor 7, right? That will help you simplify the.
Isn't 4 not 7?
That will help you simplify it before you do the factorization method.
That's 40.
Okay? You understand? You cannot use your calculator.
Okay.
Yeah? You use your calculator, sometimes you get it wrong. So you know how to do not they call it the what box method or something. Yeah, something like that. Okay? So you just solve for k then after that. Okay? Okay, so that's how you solve this. Okay, so for the